Hello and namaste everyone. Again, I am here. My name is Neha Verma. I am assistant professor from Department of Electrical Engineering, Medi-Caps University in Indore. And today our discussion topic is resistance. Okay, so here I am sharing my screen. So basically, to understand the characteristics of resistance, we will cover this presentation in two parts. Okay, so in the first part, we will discuss that what is resistance and how the resistance can be reframed in terms of electrical engineering or in terms of electricity. And then we will see the definition of resistance, its standard symbol, and various types of resistance, their physical construction, and finally the physical appearance of a carbon film resistance and some parameters which are associated with the resistance values. All these topics we will cover in the first part of this presentation, and in the next part or in the second part of the presentation we will understand the color coding and how to define the rating of any particular resistance using this color coding. So it will framed as color coding and decoding, and we will do some basic example to understand this concept. Okay, so let's start with this presentation. So first of all, uh, in general, we will not going for we are not going for electrical terms, but basically what is resistance? As a word, we can say resistance is the offered opposition by anything. Resistance is the property which represent the offered opposition. But basically, in terms of electricity, if we will talk about the electrical materials or the conductors or any material which we are going to use in any electrical network. Okay, so the physical property of these material by which they resist the flow of current within their body is represented as electrical resistance. So basically, whenever a current will starts to flow through a conductor, the flow of current will be opposed by the conductor molecules, and this opposition referred as the electrical resistance. And if we are dealing with an electrical network, and if we in at any point we want to control or limit the current, or we want to regulate its value, then the device which is used for this purpose is called as a resistor. So basically, it is a two-terminal passive component which is used to regulate or limit the value of electric current in a given electric network. And here the passive term represent that this two-terminal component is a passive element and consumes electricity. So across its terminal, we can calculate the active power. So Sir George Simon Ohms is a German physicist who gives a fundamental law that the current flowing through a conductor is directly proportional to the potential difference across it, and that law is very known and known as Ohm's law. So the proportionality constant will be represented by the electrical resistance, and due to the honor of Sir George Simon Ohms, Ohms is the unit for measurement of resistance. Now, so now we will discuss about the symbol of resistance. So basically, for fixed value of resistor, this is the IEEE symbol. The zigzag symbol is the old one, and the rectangular block symbol is the new one. So for the fixed value resistor, it is represented as shown here. And if the value of resistance is variable, then in that case, an inclined arrow is used upon the symbol. This inclined arrow is actually representing the variable value, not only for resistance, with other parameter also, like if you are using inductor or a capacitor, and the inclined arrow symbol is associated with their symbol, then it represents that the quantity or the parameter is variable. So these are the symbols to represent fixed and variable resistors. Now we will see some types of resistor. So basically, resistor can be classified in two categories, linear and non-linear. So non-linear resistor are the special type of resistor which have their own working principle, and they need an extra attention to understand the concept of non-linear resistor. Now in this particular lecture, we will focus on linear resistor. Thermistor, variator and photoresistor are the common example in the field of non-linear resistor. And the linear resistor can be classified as fixed and variable. So the fixed resistor are the most common, which we are used in various PCB from electronics branch, and generally the variable type of resistor like potentiometer, primer resistor and rheostat we are using for laboratory experimentation purpose. So let's see the pictorial representation of all these. So this is how the fixed and variable resistor looks like. This is a potentiometer. So using in the potentiometer there is a button, and by using that knob you can select the particular value of resistance for your application. This is the rheostat. In the rheostat there are two contacts, one is moving and one is fixed. So the effective resistance will be measured between these 2 points, and this section is representing the fixed resistor stream, where basically metal film and carbon film resistors are used. They again classified as thin film and thick film resistor. So these are the in the non-linear resistor stream, surface mount resistor are most common, and they are used in various applications. So for more clarification about their constructional details, let's discuss the physical appearance of carbon film resistor. So basically, to make a carbon film resistor, we should use a cylinder. This is a ceramic cylinder, and ceramic is an insulating material. So the resistance property of the ceramic is ceramic is used as a resistance to make a resistor. So this is a ceramic cylinder, and a thin layer of carbon is coated on this cylinder. So if you cut a cross section view, so it will look like as here this white portion is representing the ceramic cylinder, and the black periphery is representing the thin carbon coating on the ceramic cylinder. And now to connect this resistor to the electric network, we need metal contacts, obviously. So for this purpose, we will add two metal contacts each side of the cylinder. These metal contacts are known as end connectors, and these contacts, for connection purpose, these contacts will be connected to lids and lid. So by soldering these lead between 2 points, we can connect this resistor in a particular circuit. And now for complete assemble, complete assembly, we will coated this thin carbon film resistor by a coating of paint, and on which we can do the color coding, so that we can determine the rating. So this is how color coding of the resistance has been done for the determination of rating of this resistance. So basically, the first band represent the first digit, second band represent the second digit, third band represent the third digit, fourth band represent the number of zero, or we can say it multiplier with 10 raised to power, and fifth band is represented as the tolerance. That tolerance, the term which can this term can be easily understand as if a resistance have value of 100 ohms and it has 5% tolerance, so the value of 100 ohm resistance can be vary from 95 to 105. So it is the allowed variance in the value of the specific resistance. Okay, as the value, as we are using these resistance as the fixed value resistor. So this is how carbon film resistance looks like. Now we will see some parameters associated with the resistance. So the value of resistance basically is directly proportional to the length of the material and inversely proportional to its cross section area. So it will be represented by resistance law, and resistance law states that the value of any resistance of any conductor is directly proportional to its length and inversely proportional to its cross-sectional area. And if we remove this proportionality constant, then it will be represented by rho, and rho is the specific resistance or resistivity, where resistivity is the property by the virtue of which any material opposes the flow of current or the flow of charges within its body. So this is the basic law of the resistance. Thank you so much. This is all for the first part of the resistance. In the next part, we will learn about the color coding system of a resistance, and what is color coding and how we will do color coding on the resistance, and how we can decode the codes to identify the rating of the resistance. All these data we will discuss in the second session. Thank you so much.